Now it is example 3.8. Four arms of Wheatstone's bridge have the following resistances: AB equal to 100 ohm, BC equal to 10 ohm, CD equal to 5 ohm, and DA equal to 60 ohm. Okay, and a galvanometer of 15 ohm resistance is connected across BD. Calculate the current through the galvanometer when a potential difference of 10 volt is maintained across AC. So even if the diagram looks Wheatstone's bridge, it's not balanced. You know, for a balancing bridge, the condition is Ig to be equal to 0. And here you are asked to find the current through the galvanometer. So it's not balanced actually. Okay. Or you can look for the balancing condition, whether R1 by R2 is equal to R3 by R4. It's not like that. So it's not a balanced Wheatstone's bridge. And you're asked to find the current through the galvanometer. So we have to take the different loops in this diagram, then write to the loop equations, KVL for those loops. That way we will proceed. So for the loop BADB, it is minus 100 I1 minus 60, not minus, plus 60 I2 minus 15 Ig. Here 15 is the resistance of the galvanometer and Ig is the current through the galvanometer. Simplifying this equation, dividing throughout by 5, we have minus 20 I1 plus 12 I2 minus 3 Ig is equal to 0. So call it as equation 1. Now coming to second loop, that is BCDB. So we have I1 minus Ig into I1 minus Ig into 10, okay, minus I2 plus Ig into 5 minus 15 Ig is equal to 0. So simplifying, we have 10 I1 minus 5 I2 minus 15 Ig, not minus 15 Ig, minus 30 Ig. Minus 30 Ig is equal to 0. So one more step you can write, that is simplifying, that is 2 I1 minus I2 minus 6 Ig is equal to 0. So this is the simplified form of this equation, 10 I1 minus 5 I2 minus 30 Ig equal to 0. Okay, simplified form of that equation is this one, that is 2 I1 minus I2 minus 6 Ig equal to 0. That is the second equation. You can call it as second equation. Now we will discuss the third equation with the loop ADCEA. So for the loop ADCEA, for that loop we will write to the equation. So it is I2, 60 I2 plus 5 into I2 plus Ig is equal to 10 volt. So it was for ADCEA. So simplifying, we have 65 I2 plus 5ig equal to 10. So solving, we have, simplifying, we have 13i2 plus ig is equal to 2. 13i2 plus ig equal to 2. Let's call this as equation 3. So we have 3 unknowns and 3 equations. We can solve these equations and find I1, I2 and ig. Now example 3.9. In a meter bridge, figure 327. So that figure is shown here. The null point is found at a distance of 33.7 centimeter from A. If now a resistance of 12 ohm is connected in parallel with S, the null point occurs at 51.9 centimeter. Determine the values of R and S. So here our expression, it is what R by S is equal to. So this is a balanced Wheatstone's bridge. The balancing length is mentioned here. So the expression, that means condition for balancing, it is R by S is equal to L by 100 minus L. This is the balancing condition. Okay, so first of all, it's given the null point was found to be at 33.7. So L is 33.7 and 100 minus L will be 66.3. So our expression becomes R by S is equal to 33.7 by 66.3. Okay, so we got first equation. Now what is the change taking place? A resistance of 12 ohm is connected in parallel with S. With this S, another resistance, how much is that resistance? 12 ohm is connected in parallel. 12 ohm is connected in parallel with S and the null point occurs at 51.9. Okay, if so, determine the values of R and S. So from the basic logic, here there are two unknowns. Which are the two unknowns? R and S we have to find. So the two unknowns are R and S. So to find two unknowns, minimum number of equations required is 2. So that's what we should think about. How to get the two equations. The first equation we already got, that is R by S is equal to 33.7 by 66.3. Now how to get the second equation? So first when in the second equation S, it is not there. S is connected in parallel with the 12 ohm resistor. So there is a parallel combination of S and 12 ohm. So that equivalent resistance we write as S equivalent. So our equation becomes what? R divided by S equivalent. Instead of S, it becomes S equivalent. That is equal to 51.9, because balancing length now it is 51.9 divided by what? 49.1. Not 49, 48.1. So R by S equivalent is equal to 51.9 by 48.1. Now the two equations you have to solve. So the thing is this, you have to substitute for S equivalent. What will be S equivalent? When 12 and S are connected in parallel, S equivalent is given by 12S by S plus 12. That you have to substitute in this equation. Then the two equations you have to solve and get what are R and S. So we have the two equations we are dividing. That means we have to substitute for S equivalent. So our expression, it becomes what? When we substitute for S equivalent, R divided by 12S divided by 12 plus S it is. So 12S divided by 12 plus S, that 12 plus S goes to numerator. That is equal to what? 51.9 divided by 48.1. This is the equation. Okay, second equation. Now just to divide the two equations. So R and S will get cancelled and you will get this equation. Okay, so this equation you will be getting. So we have 51.9 by 48.1 is equal to S plus 12 by 12 into R by S. So here we have substituted for R by S, 33.7 by 66.3. Now solve that equation, you will get S. So we are getting S as 13.5, and using the value of S, you can find the value of R. That we will get around 6.86. Calculations and all, no, you have to do yourself. Okay, you can use your logarithm table. You have learned how to use logarithm table. So use logarithm table and do the calculation. It's a lengthy calculation. Now coming to the next problem, that is example 310. A resistance of R ohm draws a current from a potentiometer. The potentiometer has a total resistance R0 ohm. A voltage V is supplied to the potentiometer. Derive an expression for the voltage across R while the sliding contact is in the middle of the potentiometer. Sliding contact means that jockey. Okay, so when it is in the middle, we have to derive the expression for voltage across R. Okay, so here it is given a resistor R draws current from, this resistor R draws current from potentiometer. Potentiometer has total resistance R0. So instead of showing those different layers, no, it's just shown as a resistor R0. Its resistance is R0. Now voltage V is applied across potentiometer wire. So across potentiometer wire, voltage V is supplied. Now we have to obtain the expression for voltage across R when the sliding contact is at middle of the potentiometer. In this question, we are asked to find the potential difference between the 2 points A and B. It's asked to find the what voltage across R, that is the same as the voltage across A and B. So when we look, actually between the points A and B, two resistors are connected in parallel. Which all resistors are connected in parallel? R and half of R0. How can you say that it is half of R0? It's given that sliding contact is in the middle of the potentiometer wire. So, you know, resistance is directly proportional to length. So, if the sliding contact is at the middle, so half the portion will have the resistance half. That means it is having a resistance R0 by 2. This half portion is having resistance R0 by 2. So, between A and B, actually R0 by 2 and R are connected in parallel. Okay, you are asked to find the potential difference across R, means that is the potential difference between the points A and B. So how can we find that potential difference? So what is the current passing through the potentiometer wire? That into the effective resistance of A and B. That means effective resistance between A and B will give you the potential difference across R. I repeat, the current through potentiometer wire, suppose that current through potentiometer wire is R, means I. Okay, then that current into effective resistance between A and B. Effective resistance between A and B means the parallel combination of R0 by 2 and R. Okay, let that resistance be R1. So, if R1 is the effective resistance of R0 by 2 and R, then IR1 you have to find, where I is the current through potentiometer wire. So, first step is to find current through potentiometer wire. Okay, so we have, first we will find R1. So, before finding current, we are finding R1. So, it is parallel combination. So, by applying the equation for parallel combination effective resistance, we will get R1 to be R0 into R divided by R0 plus 2R. So, that is the expression for R1. Now, the total resistance between A and C. So we have to find the current through potentiometer wire. V is the voltage applied. Current will be what? I is equal to V divided by total resistance. What is total resistance? The resistance between A and C. The resistance between A and C means it is the sum of resistances. That means resistance between A and B and resistance between B and C. So resistance between A and B, what is the resistance between A and B? That is R1. Then what is resistance between B and C? Between B and C, the resistance is R0 by 2. So R1 plus R0 by 2 is the total resistance between A and C. So our expression for current, it becomes I is equal to V divided by, okay, the total resistance is R1 plus R0 by 2. So when you substitute for R1, you will get the expression for current. So I is equal to V divided by R1 plus R0 by 2. That is the same as 2V divided by 2R1 plus R0. Now the voltage across R, it will be I. That means I into R1. Therefore V1 is equal to I into R1. That is 2V divided by 2R1 plus R into R1. Now in this equation we need to substitute for R1. So we'll have V1 is equal to, we know R1 is equal to R0R divided by R0 plus 2R. Now substituting and simplifying, we'll get V1 to be 2VR divided by R0 plus 4R. Simplifications are there here that you can do yourself. Okay.